Once you have the speakers of your choice, and one question often asked is, how much power do I really need? In this video, we're going to do an in-depth analysis and some discussions and see how we figure how much power we need. And meanwhile, I would like to hear from you of your thinking. Okay, so let's start with the basic physics. Here we have an expression of the sound pressure or the sound level, how that calculated. So it equals to your speaker sensitivity, which is normally measured at 1 meter, minus 20 times log the distance in terms of meter where you sit. For example, if your comfort listening level is average at 90 dB and the speaker sensitivity is also 90 dB. The sensitivity is normally measured at 1 meter and input at a watts of power, and that's the speaker sensitivity. And here, the reason we use listening level at 90 dB, sometimes consider high, but if you think about it, like a rock live music concert, the sound pressure is about 110 dB. Of course, those are very loud, but I think in general, 90 dB is very reasonable, especially during the daytime. Nighttime, maybe you can reduce by half also, right? So around, say, 84 dB or 85 dB, because it's much quieter environment. Your ear will adapt to the surrounding noise. So during the day, your ear is less sensitive. You need slightly higher power to give you that kind of music feeling. Especially for HiFi music, you would like to have relatively higher level because your ear sensitivity decrease at both high frequency as well as low frequency. Meaning if you really listen at low level, you will miss a lot of content, you miss the sound stage, you miss the imaging, so a lot of sound quality will deter. So here is the assumption, 90 dB listening level. And 90 dB per watt sensitivity for speaker, especially for HiFi speaker, is not considered low. So basically this is on a high end of HiFi speakers. Most of HiFi speakers, for instance, Dynaudio or whatever, they're more on the 88 dB, and some like a B&W maybe slightly higher sensitivity, but the majority is below 90 dB. So we assume 90 dB here just for the analysis purpose. And now we assume that you sit about 4 meters away from the speaker. I think this is also a reasonable assumption. Some people may sit closer because the room is smaller, but when you get down to 3 meters, especially for floor standing speakers, you become a little bit sensitive to the vertical dispersion because your ear is not perfectly aligned. If it's aligned with the tweeter, then it's not aligned with the mid-range, or it's totally offset with the woofer. So 4 meter assumption here, I think is reasonable, and it's kind of a sweet spot. And because of that distance, right, we mentioned earlier, the speaker sensitivity is measured at 1 meter. So every double the distance, you're gonna reduce the sound level by 6 dB. So now from 1 meter to 4 meter, we reduce about 12 dB sound level. So basically, if we input a 1 watt power into the speaker, you at the listening position, you will be only getting 78 dB sound level. And here, we want to bring back that 78 dB back to 90 dB. So that means we need to increase the power input into the speaker. But how much we need to elevate that power, right? That's the question. So here is the number. For every 3 dB sound level increase, sound pressure increase, we need to double the input power into the speaker. So now remember, from 78 to 90 dB, we need 12 dB increase in sound level, and that means we need quadruple the power, right? So therefore, in order for us to bring it back to 90 dB loudness at the listening position, we're going to have roughly on average 12 watts power input into the speaker. So this is the most basic power required. And now the following calculation will based on about, say, hi-fi music. So the first thing we want to point out is that a lot of people will say, hey, the peak power is about the square of 1.4. 1.4 is voltage level above the RMS, right? So if it's a sine wave. So it's the square of 1.4 times the average power. But this is not true, because this is only true when we calculate an amplifier output power. But for music, it's totally different, because in music, especially high dynamic music content, like symphony or rock music, nowadays, modern music are mostly high dynamic music, especially for hi-fi, right? You can imagine the average level, maybe say a female voice or man voice, or maybe a main instrument like a violin or a cello, whatever. So the main constant consumed power, the main melody, we consider that as an average power, right? But we understand there are transient, like a drum, a bass drum, a bass, or lots of things, right? In the treble, like cymbals and so on. They will be much higher than the melody itself. So that's the reason we have high dynamics, right? So very quiet music, and then suddenly it could become very loud. So that's the dynamic. So how much this dynamic we need is the question. I think in general, thumb of rule is that you probably at least need 4 times more power for this dynamic headroom. So basically, say your main melody is at 12 watts, probably some high notes, very strong bass or whatever, will reach like roughly 50 watts in a short period. And in order for these kind of signal not clip, right? Because we don't want to hear the noise of clipping noise. We need at least 50 watts of the amplifier output to cover this part. Again, back to the 90 dB listening level. And then, this is a critical thing. Hi-fi music, right? For casual listening, I think 50 watts is okay because you're not clipping. But hi-fi music is not only about clipping distortion. Actually, we care more about linearity, because that is critical for music reproduction, for the high fidelity. If you lose the linearity, some notes are in low range or high range or whatever, you hear different sound waves than the actual sound wave should look like, or electrical wave. So we definitely need the linearity. Just like you have a high-end car, the reason they need that high power is that they need a linearity. When you push on the gas pedal, you immediately feel the acceleration. And the more you push, the more acceleration. The low-end car is a different thing, right? The first push you might feel a little bit, but continue push the gas pedal, you start to feel less and less kind of power into the car, or it's much less linear. So this is same thing for the hi-fi music, right? We want that linearity. How much, whatever the music notes, we want to represent exactly how it looks like. However, for instance here, if we take a look at the solid state power amplifier, and here I'm using a power transistor at the output stage, right? This is commonly used PNP and NPN pair, the MJ by Motorola are now on SEMI 21193 and the MJ 21194. These are the power transistor pair, high power, high current, very commonly used. I will show you their chart at the next page, but in general, their linear operation is only up to 3 amps of collector current versus what they rate. These transistors are rated at 16 amp, but actually it's about 5 times lower range you can use for linear operation. So if this is the case, right, 5 times, then that means we want a higher power amplifier so that they operate in the lower 1/5 of the power range so that the output power transistor are running in linear range. So meaning we need 250 watts to deliver 50 watts clean power. Now from here, it's relatively clear why the audiophiles always pursue high power. A lot of cases people argue you don't need that much power, right? But this is basically the physics behind it. You want clean power, and that's for the linearity to coverage. And meanwhile, you want to cover the dynamic range of the music content. This is make this. And of course, you want certain level of loudness. So if you read backward and then from top to bottom a few times, you understand the logic here. So now come to the numbers I mentioned earlier, right? These are the example transistors I mentioned, the MJ21193 PNP and the MJ21194 NPN. These are a pair of transistors used at the output stage push and pull. So if you look at these curves, this is collect axis is the collector current in both chart, and the y-axis is the gain, the DC gain, current gain, right? So you can see at different temperature, but no matter which temperature is at about, this is 1 amp, 10 amp, at about 3 amp also, these things start to roll off much quicker. In other words, the gain no longer linear, right? You want kind of a flat curve. No matter what kind of current is amplifying, the amplification doesn't rely on, say, how much current is drained. So you want kind of plateau, or at least a slow slope. Here, I would say 3 amp is roughly a turning point here. And for the NPN, same thing, about 3 amp. Low temperature is slightly better, but this is for negative 25 degrees. The amplifier never operates negative temperature. Most of the time, the amplifier is between, say, 25 and 100 C. I would say 50 C or 60 C is more reasonable. That's how those high-end power amplifier design at, roughly here. But again, the turning point is about 3 amps. So that's the number we mentioned earlier, right? They rated 16 amps, but actually the linear operation only up to 3 amps. So that's, you probably just want to use the first 1/5 of the power of the transistor. And this is the reason a lot of high-end power amplifier I'm showing here is the output stage schematics. And this is a full balance, right? You have a positive and then you have an inverted or the negative side. So you can see they actually put the transistors in parallel. So these are 5 transistors in parallel, so that if you want to output 16 amps, you divide the 16 by 5. So you're operating about roughly slightly higher 3 amps. So it's kind of in the linear range. And this power amplifier gives about 300 to 400 watts output. So this is the reason you need high power. And also this is how the high-end amplifier manufacturing achieve those high powers. That's all about today's discussion, and hopefully this help you to understand the physics and also help you to choose or the right amplifier for your lovely speakers. And of course, I might miss something or I could be wrong or whatever. You can put your comment in, and so that we can do some further discussions. Thank you very much. Enjoy.